Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we are from Group 8. We present to you guys about our group assignment project for static subject entitled Resultant Force. Firstly, I will introduce to you guys our group member. Our group containing 4 members. The first one is Wan Ahmad Syahid bin Wan Ahmad Salahuddin, matric number AA210707. Muhammad Khairun Ammar bin Muhammad Zuki, AA211334. Muhammad Hanif bin Jamil, AA210242. Muhammad Ikmal Mustaqim bin Badrun, AA211889. First and foremost, for the introduction, to understand resultant force much better, let us see these two scenarios. Anytime a stationary object stays still, so the resultant force of the object is equal to 0. As soon as the force is applied on the object, the acceleration will begin. The speed of acceleration will depend on the force applied on the object and also the mass of the object. Similarly, each time an object in motion in a constant speed and same direction, it also the resultant force is also 0. As soon as a force is applied on an object, it will make the object stop, change direction, or move slower and faster. The effect will depend on the force applied and also the mass of the object. It is worth noting that an object may have several different forces acting on it.
Next, background of case study. 2 groups of people are doing a tug of war and each group is pulling on the rope as hard as they can. Then, finally, which team will win? Another question that may arise that will one group be able to make the other group move? In order to answer this question effectively, we need to know how to find the resultant force. The resultant force is a single force which will produce the same effect on an object. In this case, a rope is an object, so we have to apply the concept of the resultant force. Next, I'm going to talk about basic theory. The resultant force is defined as the total effective force acting on a body along with their direction. Also, when the object is at the rest position or travelling with the same velocity, then the resultant force has to be 0. As it can be seen here, that all the forces are acting towards the same direction. Hence, the resultant force should be the same for all the force. Also, if one force is acting towards the perpendicular direction to others, then the resultant force can be determined by using the Pythagorean theorem. The resultant force formula is given by Fr equal to F1 plus F2 plus F3, where F1, F2 and F3 are the force acting in the same direction on a body. If F2 is perpendicular to F1, then the resultant force formula is given as Fr equal to square root F1 square plus F2 square. Notice that this is not merely the sum of the magnitudes of the force, but the sum of the force taken as vectors, which is much suitable. This is because vectors have both the magnitude and the direction, which we need to consider while finding the sum. Thus, according to the above equation, if an object is having no force, then the resultant force will be also 0. On the other hand, if an object is subject to only one force, the resultant force will be equal to that force. Therefore, we have to perform the vector sum of the force instead of the regular sum.
Okay, we go to analysis and calculation. For the first example, we have three forces, which is 15 Newton, 60 Newton and 20 Newton. All the force of the force acting on a body simultaneously. The direction of 20 Newton is opposite to the direction of the 50 and 60 Newton, which is to the left. So determine the resultant force. Okay, now we will answer the question. We will use basic formula for resultant force, which is F1 plus F2 plus F3. We insert all the information that we have into the formula. F1 50 Newton, F2 60 Newton, and F3 negative 20 Newton. F3 is negative because it is opposite to the other force. And we will get the answer is 90 Newton. Therefore, the resultant force for this question will be 90 Newton. Okay, now we go through to second example. The question is, if 4 Newton and 9 Newton forces are acting perpendicular to an object, determine the resultant force. Okay, the first information that we have, F1 equal to 4 Newton, F2 equal to 9 Newton. The keyword for this question is perpendicular, which is 90 degree. Okay, back to basic, we will use theorem Pythagoras formula, which is F1 square plus F2 square, then the answer will be square root. Okay, the calculation is 4 square plus 9 square, then we get answer 97. 97 we will square root it, and the answer is 9.85 Newton.
Okay, for the discussion, the resultant force is the single force that has the same effect of two or more force acting together. Two force in the same direction, two force that in the same direction produce a resultant force that is larger than the either individual force. Resultant force is nothing but the total force acting on a body, including their direction. If the object is at rest or it moves with a same velocity, the resultant force should be zero. All forces are acting on the same direction. Resultant force should be the sum of all force. Aside from that, the significance of the resulting force is useful since it allows us to examine several forces as if they were all the same. This means that to determine the effect of several forces on an item, we only need to determine that the influence of a single force. As example, in tug of war, where each team is pulling equally on the rope, is an example of balance force. Rope will have an acceleration of 0 under the action of this balance force. It will remain stationary. Changing motion include the movement where the body is speeding up or slowing down. To find the resultant force, you must carefully identify the object you want to study. In the tug of war, each team is pulling on the rope, so the rope is the object where the motion we want to study. Next, identify all the forces that are acting on the object. Each team is pulling on the rope, so the force acting on the rope in opposite direction. A great way to clearly show the force acting on object is to use a free body diagram like the one you are looking on screen. A free body diagram is a picture that represents the object with with a dot in the center and use arrow to represent the force acting on the object. The direction of the resultant force shown by the winner team, which has more force than the other side. For example, if team A use 110 Newton and team B use 20 Newton, so the resultant force will be 90 Newton. The direction of the resultant force was toward team A, and team A is the winner of tug of war. In the resultant force, if the resultant force is 0, it means that the force from both sides is equal. For example, team A use 50 Newton while team B use 50 Newton, so the resultant force is 0. So when the resultant force is 0, the velocity from the both sides will be also 0, causing a power balance to result. Okay, the last one, conclusion. To summarize, if the object resultant force is 0, the object will remain stationary. The resultant force is significant because it allows us to treat many forces as if they were all equal. To change the velocity of an item, eminence force is necessary. The thing moves at a constant pace in this situation. Aside from that, the resultant force is available everywhere because the nation is so basic, and there are several advantages to using this approach. We may balance an object with them, and the thing will be stronger as a result of the consequence force. Finally, when multiple force act on an object, a resultant force is formed. In the pot of for example, there is a machine that raises container. The machine weight appear to be uniformly distributed and does not revolve. This is due to the fact that the resultant force is 0. When the object reaches force equilibrium, there is no net force exerted on it, and it is either stationary or travelling at consistent speed. Okay, that's all from us. Thank you.